This video will cover chemical and physical properties and changes. This should be a review from things you have heard in middle school and high school. Physical properties describe a substance as it is without it changing. So we can just take a particular material in front of us and describe things like its size, its shape, its temperature, its color, its density. So it's going to include these things and what phase it is. It would also describe a general substance. For example, water. I could describe for water the properties that it has: boiling point, heat capacity, density. So I don't have to have a specific example of water to have those things.
Some of the physical properties of water are that it is a liquid at room temperature, that it is clear, and that it does not have a color by itself, that its boiling point is 100 degrees Celsius, and its freezing point is 0 degrees Celsius.
Physical changes are going to involve, of course, changes in these physical properties. So if something is only a physical change, we might see things like phase changes. So when a material boils or melts, a change in temperature. So that could happen even if it doesn't change from a solid to a liquid or other phase change. And could be a change in size, as if something increases in size when it heats, or if we cut something into smaller pieces. If I have only a physical change, the substances don't change. This means no bonds are broken or formed, and so all of the molecules are the same. And usually we don't have a name change for those substances. Water is an exception. We call it something different at a solid. We call it ice. We call it water when it is a liquid, and we call it steam when it is a gas. But the molecules of ice, water, and steam are identical. Often physical changes are easily reversed. For example, if I have something that I've frozen, I can melt it by heating it up. But this isn't 100% true. For example, if I tear a piece of paper, that's a physical change, but it's not easy to put it back together. So the one reliable thing is whether or not I have new molecules.
Here we have an example of butter in its solid form. Now we're going to put some on a hot pan and see what happens. So the butter in solid form is a mixture, and it has certain molecules, many of which are fats, some of which are water, or some others.
The chemical properties of a material involve how it will react, either in response to energy changes like heat or with other chemicals. So we might describe whether something is flammable or combustible, or we might say when it is around air, it will rust, or when it is around acids, it will dissolve. Or we might describe acids as being corrosive. Those are all chemical properties, how they react.
Some of the chemical properties of water include that it will not combust or burst into flames, and that it does react violently with the pure alkali metals.
Chemical changes are changes that occur where a new substance is formed. So usually there's a new name when I have new substances formed. If I mix together baking soda and vinegar, I'm going to get some bubbly action going on, and those bubbles contain carbon dioxide. So I'm going to see some new things with new names. Now, when it comes to food, sometimes we just call it the same thing before and after the chemical change. So we might call an egg if it is raw and if it is cooked, but chemical changes have taken place. Often we can recognize chemical changes because there would be new colors or new phases. So in the example of an egg, it would be a liquid at room temperature if it is raw, and it would be a solid at room temperature if it is cooked. In chemical changes, bonds are broken or formed, or both, in order to form these new substances. And it usually requires or gives off energy changes. So this might mean that is accompanied by temperature changes. When I do the reaction to cook an egg, a lot of heat must be put into the egg in order to make it cook. Sometimes chemical changes will give off a lot of heat, as if I strike a match and am burning the wood. That gives off a great deal of heat. So when I see extreme energy changes, that's often an indication that chemical changes are occurring.
Here we have a raw egg. Now this is one of the exceptions to our rule about name changes. So raw egg in this circumstance, we have the yolk and we have the white. The white is made up of water and protein, and the yolk has some protein, some fats, some xanthophiles, and some other chemicals in there, some cholesterol. And so they're a liquid at room temperature and even at colder temperatures. We can take the egg and put it in a hot pan and watch what happens as it heats. Now normally we would expect as we heat a solid it would become a liquid, and as we heat a liquid it would become a gas. Those would be phase changes, that would be physical changes, but as we are watching this egg, the liquid is in fact turning into a solid. So here, after it's been cooking for a minute or so, we have a mostly solid egg. And when we return it back to room temperature, it's not going to turn back into the liquid state. It's going to remain a solid. So this is an indication that we have new substances that with the property that they are solids at room temperatures rather than substances with the properties of being liquids at room temperatures. So even though we still call it an egg, it has had a chemical change happen to it. Here I have a measuring cup with about a quarter cup of water, and into it I'm pouring some sugar, and as I stir that sugar, eventually it's going to start to dissolve. Now as it dissolves, we can no longer see that sugar. However, the sugar is still present. We can tell this because if we taste it, it would taste sweet. Same thing with salt. The sugar molecules don't change in any way as we dissolve them. All they do is separate from one another and allow the water molecules in between. And once this is well stirred, the solution will be as clear as water itself. So here you can see the sugar is almost entirely dissolved, and the solution looks much like water. Now sugar has an unusual property in that it is so like water, it has polarity and hydrogen bonding, that you can dissolve a great deal of sugar in water. So even though we only had a quarter cup of water, I've added half a cup of sugar, and I'm going to stir this, and it's also going to require some heating as well, but we're going to be able to dissolve all of this material in here. As we heat the water and sugar mixture, you can see it's starting to take on a bit of an amber color. That is an indication that we are starting to form some new compounds as the sugar molecules are breaking down. These new compounds will add flavor to the result of this that give caramel its flavor, including things like diacetyl, which will give it a buttery flavor, and some other chemicals that give the unique flavor of caramel. When we look at a slice of bread and think about what kind of changes might be happening when we toast it, we might consider the color changes and the changes in the consistency of it. So bread that is not toasted has some give to it. It's not as brittle. So let's see what happens when we toast it. After it has been toasted, the bread is drier and more brittle, and it has also changed color. First, what happens is the moisture that is in the bread, the water, evaporates off. So bread is a heterogeneous mixture. We can see that it's a foam, that it has air bubbles, but there's also water that's trapped in there as well. And that's just going to evaporate off. And so evaporation is a physical change. But as we let it continue to cook, we see evidence of the chemical change as we have the whiter starches turning into darker brown colors as those starches start to decompose and form smaller molecules.